here going on. If for some reason you're confused, watch this video. You're legit going over what is called the remainder theorem. Okay. Basically, what this remainder theorem tells us is for any polynomial with real coefficients, but I'm not going to add that. And we'll call our polynomial p of x. The remainder of p of x divided by quantity x minus a equals p of a. So we are getting into division. But here's what this means. If I wanted to say have p of x, my function, let's say that's x squared plus 3x minus 5. I'll do an easy one. And I wanted to find p of 3. One way to do that is to literally put in the 3 and evaluate and get an answer. Now, I did that by evaluation. I did not use the remainder theorem. But the remainder theorem gives me an alternative way to evaluate that is actually faster than actually evaluating. So if I take my 3, and hopefully you remember synthetic division, I take each of my coefficients, bring down. Do you remember doing this last year? Multiply, add, multiply, and I did it wrong. How did I do it wrong?
3 plus 3 is not 9.
3 plus 3 is not 9, it's 6. Thank you.
Is that supposed to be
18.
13 on the bar list?
Yeah, this is 18 minus 5, which is 13. And then negative 5 plus 18 is 13. That's my remainder. Notice it's the same. So basically, we can use synthetic division to evaluate.
Wait, so how did you do that? You scribbled it all out.
I'll do another one.
So is that what we're doing? Just synthetic division?
Yep, pretty much synthetic division. Let's do another example. Let's say f of x equals 4x to the 4th minus 3x cubed plus 2x squared plus 1. And I want to find f of 2. I'm going to use synthetic division. So I set up my synthetic division, which is going to be the coefficients of each of these. Now if I'm missing a term, that term is going to be 0. So we'll do one that's like that. So I set up my synthetic division. I take each of my coefficients, draw my line here. Right here is the number I'm going to divide by. Now I'm dividing by x minus 2, which is the same as taking this opposite in sign and putting it there. My remainder is right here. This is my remainder. My last thing.
Why wouldn't there be a 0 or the x?
Oh, you're right. My bad. Oops. My bad. Good catch, Josh. I am missing a term, aren't I? I'm missing the x term. Good job. So this is our remainder. Yeah, if we don't have that extra 0, that actually does throw off the answer. Alright, so now we synthetically divide. So we bring this down. Now we multiply 2 and 4 and get 8. And then we add. And we get 5. Then we multiply. We add. We multiply. We add. We multiply. And add. Our remainder should be 49. So that means the f of 2. If I put 2 into this, I get 49. This is by far faster than actually putting the 2 into here and doing all that work. Of course, if you're using a calculator, then it probably makes no difference to you. But there's other uses for this. So let's talk about the next use. All of this stuff, if I decrease it by 1 power, is what I would get. If I did x minus 2 and I divided it into this, then all of this is what would go up here in the quotient. So I'd have 4x, not to the 4th though, because I essentially divided by an x, so it's x cubed, plus 5x squared, plus 12x, plus 24, and our remainder was 49. So I can do my synthetic division instead of doing the long division right here. Okay, the factor theorem. If the remainder of p of x divided by x minus a is 0, then each of the following. First, x minus a is a factor. Therefore, x equals a is a root. So, for example, let's say I have the polynomial there's my polynomial, and I want to find all the roots, all the real roots. So what I'm going to do is I'm going to set up my synthetic division. This time I don't know what I'm going to divide by. Let's make sure I get all the terms. Got them all. So I'll set this up, but the question is going to be, well, what am I going to divide by to figure this out? Well, I want to know my possibles. That way I narrow what I actually synthetically divide by. And my possibles are the factors of the last term, when I have these in order, over the factors of the first term. So in this case, the factors of the last term are 1, 2, 4, and 8, because they're the factors of 8. And the factors of the first term are the 2, that's going to be 1 and 2. Now you don't have to, unless you're specifically asked to, you don't need to write out all the possibilities, but first I take all of these and put them over 1. So I have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, and plus or minus 8 over 1. So just plus or minus 1, 2, 4, 8. Now I do them all over 2. So plus or minus 1 over 2, plus or minus 1, plus or minus 2 over 2, which I don't need to account for because that reduces to a 1, plus or minus 4 over 2, which reduces to 2, so I don't need that one, that's a repeat, and plus or minus 8 over 2, which reduces to 4, so I don't need that one. So these are my possibles. So those are the only ones that I'm going to test in my synthetic division.
Where do you get 1, 2, 4, and 8 from?
The factors of 8. Last term, factors of the last term, or the factors of the first term. Alright, so let's try -1. So let's just see what happens. Don't write this down until we get it to work. So we get 2, -2, -9, 9, 1, -1, and I see that I'm not going to get, I need a 0 as my remainder. So that didn't work, so not -1. Let's try 1. That should be 2, -5. It might be that this polynomial doesn't have any real factors. That's a possibility. We're getting closer. That didn't quite work out. Let's try 2. So 2, 4, -3, -6, -14, -28. Am I adding these right? So that's -14, which is not going to give it to me. Maybe -2? What do you know? I would pick the one polynomial the book gives us that actually doesn't have any. 16? No. 14. -28. 14 again. That would be positive, yep. That would be negative. And that's going to be -28. So that doesn't work. I bet none of them work. Well, let's try half. 1/2. 2, 1, -6, -3, -11, and now we're going to have a half thing, so that's not going to work.
Yeah, if it works or not.
Well, actually, we could cheat and graph this and just see if there are any, but I didn't bother doing that. We need a remainder of 0. That's what the factor theorem says. If the remainder is 0, then it works. So I'm stopping when I get here because I'm recognizing, well, I'm not going to have a remainder 0. So let's try 4. I think it's just going to get worse, but I could be wrong. Let's see, -4. Oh, wait. -2, -8, remainder 0. 4 works. Okay, so that means x equals 4 is a root. Therefore, x minus 4 is a factor. You will be asked for both of those. You might even be asked to factor these, in which case you're going to need to do this synthetic division multiple times. So, I'm actually not done. I didn't find all the roots. I found one of them. One of them is 4. So I'm going to erase this bottom portion here, because we already have that. Now, I'm going to take this. See, this is my factored form down here. So this actually means 2x, see, decrease that by a power of 1, plus x squared, decreased by a power of 1, minus 4x minus 2. See, this is my new polynomial, is decreased by degree. So I'll take all of those coefficients, 1, 2, 1, -4, -2. I'll set up another synthetic division, and here's my remainder. That's what I'm looking for. Now, we had already tried, let's see, 1, -1, a half. Now we didn't try negative a half, so we might try negative a half. We tried 4. We also tried 2 and negative 2, right? So we don't need to try any of those again. So we could have negative 4, we could have negative a half, and we could have 8. Let's try negative a half. Just see what happens. So we get 2, negative 1, 0, which is 0, negative 4, and then when I multiply that, I get 2, and a remainder of 0. So this is another root. So x equals negative a half is another root. Which means if x equals negative a half is a root, that means, now here's how we figure out what the factor is. I clear the fraction, that's going to be 2x equals negative 1, add the 1. Therefore, 2x plus 1 is the factor. Alright, now I'm down to this. Let's see. Decrease all of these by power 1, that's 2x squared. 0 x's and minus 4. When I get down to this, there's really no reason to do synthetic division anymore. I go ahead and I try to factor it. So I could factor out a 2, right? And this is actually factorable. It doesn't come out nice, but it is factorable. I could factor out, I could factor like minus root 2 and x plus root 2. We'll practice some of those. So, my other roots from that are x equals root 2 and x equals negative root 2. Did we get the synthetic division done? Can I erase that? I'm going to get rid of the synthetic division. So as you whittle down the synthetic division, once you get it to squares, you can use quadratic formula in factoring. So these are our roots, which means we had x minus 4 as a factor, 2x plus 1 as a factor, x minus root 2, and x plus root 2 as factors. That means p of x factored is this. Alright, let's recap what we've talked about, and we'll actually finish this section tomorrow. Okay, let's say I have f of x is, and I'm going to use the same f of x for both our questions, 3x cubed plus 4x squared minus 5x minus 2. Alright, let's say I want to find f of negative 4. Yes, I could put in negative 4, but we're going to use it doing the remainder theorem. So I'm going to set up my synthetic division, negative 4, 3, 4, negative 5, negative 2, and my remainder is whatever that is. So I do my synthetic division. Bring down the 3, multiply, add, multiply, add. What did I get there, 27? Multiply, add. So f of negative 4 should be negative 110. And you could easily check that by just putting in the negative 4 on your calculator. Alright? Now, let's say I want to find, let's say I want to factor and find the roots. Now your book, when they ask you this, or on a test or quiz, you would probably be asked to do these separately. So you need to mind which one you're doing. I'm just showing you both of them because it's the same set of steps. I set up my, now we know we don't have to test a negative 4. So what I'm going to do is I set up my synthetic division, And when you are doing this on your own, you might write this in like pen and then use your pencil so you can erase real quick without needing to, I don't know, whatever. I need to list my possibles. My possibles are factors of the last over factors of the first. So my factors of the last are 2 and 1, and that's it. My factors of 3 are 1 and 3, and that's it. So I have plus or minus 1, plus or minus 2, 1 over 1, 2 over 1. And then I have 1 over 3 and 2 over 3. Any questions on where I get that? These are my possibles. So I don't have that many to test. I have a total of 4 times 2, so 8 to test. So, I mean, these numbers aren't very big. I might try 1 first.
Would a half be in there somewhere?
Factors of 2.
I never know.
Yeah, it's a third. Anyways, we're testing 1. Multiply, add, multiply, and lucky. Now, if you want to save yourself some time, certainly you could graph this on your graphing calculator, use your gsolve function, find your roots that way, and then you know which ones to test on your synthetic division. Make sense? Or at least you don't even have to gsolve it, you can see about where they are. Alright, so I have x equals 1 is a root, which means x minus 1 is a factor. Now I take this, decrease it by a power of 1, see it's power 3. And now this is I don't need to do a synthetic division once I get it down to a quadratic. I can try to factor it. And it does factor. So those are other factors, so I get x equals negative 1/3, which means 3x plus 1. And x equals negative 2, which means x plus 2, which I already have. So if I multiply all those together, that would be that in factored form. And these are my roots. Root, root, root. Easy. You're doing basically for this section the same thing. All the uses of synthetic division.